Hello YouTube. Right, back to the wheel. I had some problems earlier when I was talking about going into the negatives on my multimeter that I'd got at the moment. At the time it was a clamp meter. The clamp meter unfortunately hadn't got the accuracy I wanted, and therefore it was giving me false readings. So I've gone over to the old analog display here, made a few modifications. I'll try and get square to this meter, and you can see I've got a scale of 300 milliamps, and I'm currently running at 10 milliamps. A reduction, and how I've managed to achieve these reductions. Firstly, listening to what MrAnguswangus said, I've loaded the coil iron, the inductor, with iron at the back. I've used what I call my edge rod over the top, and I've closed the gap on my magnets. So now the gap that you see there of roughly about 5 to 7 millimeters is the distance between there's metal inside of the wheel. So what I've got is a permanent magnet and then a chunk of metal going from the permanent magnet, touching the permanent magnet, to within the grey rim on that wheel. I've drilled the slot hole all the way through as well, so that not that it'd probably make any difference to plastic, but the flux has a free path straight to the metal, so it jumps at 7 millimeters, touches the permanent magnet, jumps from the permanent magnet for the gap to my Bedini. What did that achieve for me? Also, followed what MrAnguswangus says. I've now gone north-south, north-south on my magnets, which has increased the motor in terms of the output. I'm charging batteries with this output. I know MrAnguswangus on his energy systems video wasn't charging, but I am actually charging through the capacitor. I charge onto the charge battery here. This battery is totally annihilated. It's about 8 volts at the moment, and climbing. It started at 8, I don't know if you can see that, 8.25 volts. So I'm going to leave that on and see how it goes. So basically, yeah, that's my start setup. And after talking with MrAnguswangus late into the early hours one evening, I wasn't quite getting it, but now I think I have totally got it. I've ordered my LCR meter, a few other bits and pieces. I've got a new clamp meter coming with the resolution I want to be able to measure in milliamps, so I can detect it, what I'm doing from there. So this is my sort of my start motor, and as you can see I'm running now at 10 milliamps. So hopefully by the time I've got things more worked out in measurements, and it is about the math. I hate to say, because I hate the math, but I've realised what he was saying. It is the equations, it's the math, working out the induction reactance of the coil to the metal you've got, measuring what you've got, getting the impedance, increasing impedance as much as you can so that you reduce the current. So my next section, if I add another coil, which I've got another coil I've made up, which is going to go on the motor. In fact, I've got 2 of these now, so I can put another 2 coils onto this motor and try and get 10 milliamps down a lot more. But I ain't going to mention any figures yet, just like MrAnguswangus. I'll do the math, and hopefully that figure should get divided each time. I want to get, by the time I've finished with these type of coils, I want to get this motor running on something like 2 milliamps. You never know. We'll see how it goes, but that's what I'm aiming for. But it's bang on. It's a case of looking at the equations, doing the math, working everything else. Loads of iron helps, and that's it basically. That's all to report at the moment. We'll see how it goes.